Let us continue with the topic monohaloalkanes. Last class we have discussed with the methods of preparation of monohaloalkanes or alkyl halides, and we have discussed the chemical properties. The first chemical property, that is dehydrohalogenation or elimination reaction, wherein we have discussed about a rule called as Saint-Joseph's rule. Now the second set of reactions are nucleophilic substitution reactions. Before going to the details of these reactions, you should know what are electrophiles and what are nucleophiles. Electrophiles are electron deficient species, whereas nucleophiles are electron rich species. Now here alkyl halides readily undergo nucleophilic substitution reactions for the reason that in alkyl halides the halogen atom is more electronegative than carbon. Hence the carbon halogen CX bond becomes polar. Carbon attached to halogen bears partial positive charge, while halogen bears a partial negative charge. Thus the nucleophile readily attacks this positively charged carbon, and hence halogen acts as a leaving group. It is readily eliminated. There are different nucleophilic substitution reactions of alkyl halides. The first one is reaction with aqueous potassium hydroxide, or even sodium hydroxide can be used. Let us look to the reaction. Alkyl halides react with aqueous potassium hydroxide solution on heating to give corresponding alcohols. ROH is the general formula of an alcohol. If you look to the elimination reaction, the reagent used there was alcoholic potassium hydroxide. So you can compare here. If alcoholic potassium hydroxide is used as the reagent, dehydrohalogenation takes place and the product formed will be an alkene, whereas if aqueous potassium hydroxide is used, then nucleophilic substitution takes place, that is X minus nucleophile is substituted by OH minus nucleophile, and you get the corresponding product as an alcohol. For example, if you heat bromoethane with aqueous potassium hydroxide solution, the corresponding product formed will be the alcohol ethanol, C2H5OH. Now the next nucleophilic substitution reaction is reaction with sodium alkoxide. The group alkyl is represented by capital R. Alkyl group R plus oxygen gives you RO alkoxide group, and the formula for sodium alkoxide will be RONA. So here alkyl halides react with sodium alkoxide on heating in alcoholic medium to give the corresponding organic compounds called ethers, having the general formula ROR-, where R and R- are the alkyl groups. Now ethers have the general IUPAC name alkoxyalkane. To look one particular example there, I have taken bromomethane on heating with NaOCH3, that is sodium methoxide in alcoholic medium. The corresponding ether formed is dimethyl ether, which is the common name, and its IUPAC name will be methoxymethane according to the general IUPAC name alkoxyalkane. Now this is a named reaction. It is called as Williamson's ether synthesis. So this is the second nucleophilic substitution reaction. Now coming to the next nucleophilic substitution reaction, that is reaction with alcoholic ammonia. As you all know, ammonia is a gas. If you pass it into alcohol, you will get an alcoholic solution of ammonia. Its formula is NH3. It contains 3 replaceable hydrogen atoms. Now alkyl halides react with alcoholic ammonia. The reaction is carried out in a sealed tube. NH2 minus nucleophile replaces X minus nucleophile to give the corresponding products called as primary amines, having the general formula RNH2. If in the reaction mixture alkyl halide Rx is taken in excess, then further substitution of the primary amine takes place to give the corresponding secondary amine, tertiary amine, and finally quaternary ammonium salt. To take one particular example, CH3Br, that is bromomethane or methyl bromide, on heating with alcoholic ammonia in a sealed tube will give you methyl amine as the product. If methyl bromide is in excess, further substitution takes place forming dimethylamine, trimethylamine, and finally tetramethyl ammonium bromide. So this is the reaction of alkyl halides with alcoholic ammonia. Now the next reaction is reaction with alcoholic potassium cyanide, KCN, dissolved in alcohol. Now CN nucleophile cyano group replaces X- nucleophile and the product formed is called as alkyl cyanide. Alkyl cyanides in the IUPAC system have the IUPAC name as alkane nitriles. So to give one particular example for this reaction, let us take iodoethane. Iodoethane is represented by C2H5I. On heating with alcoholic potassium cyanide gives the corresponding alkane nitrile as propane nitrile. Remember, the name propane here is given to the nitrile because the cyano group carbon is also included in numbering. So therefore there are 3 carbon atoms, hence the IUPAC name propane nitrile. The next nucleophilic substitution reaction is reaction with alcoholic silver cyanide, AgCN. Now if you look to the previous reaction and compare it with this reaction, CN nucleophile is present in both cases, but here nitrogen of CN group forms bond with the alkyl group, so that the corresponding products formed are called as isocyanides, alkyl isocyanides. So alkyl halides on heating with alcoholic solution of silver cyanide gives corresponding alkyl isocyanides, which in the IUPAC system are named as alkyl carbylamines. To give one particular example, bromoethane on heating with alcoholic silver cyanide gives the corresponding isocyanide as ethyl carbylamine, C2H5NC. So the next nucleophilic substitution reaction is reaction with alcoholic potassium nitrite. KNO2 is the formula of potassium nitrite. So if you look to the reaction here, alkyl halides RX react with potassium nitrite. The structure is represented here, KON double bond O. So K plus and X minus is eliminated as KX, whereas oxygen adjacent to potassium atom will form bond with the alkyl group R, so that the corresponding product formed is RON double bond O, called as alkyl nitrite. The example taken here is chloroethane or ethyl chloride on reaction with alcoholic solution of potassium nitrite gives you ethyl nitrite as the product. Now if you compare this reaction with the next nucleophilic substitution reaction, that is reaction with alcoholic silver nitrite, in place of K here it will be Ag. But if you look to the reaction here, nitrogen atom which has lone or unshared pair of electrons will form bond with the alkyl group, so that you get the corresponding products as nitroalkanes. Look to the structure there, Rn plus O minus double bond O, which is a nitroalkane. Example taken is bromoethane or ethyl bromide on heating with alcoholic silver nitrate solution gives you the product as nitroethane. This is another nucleophilic substitution reaction. Now coming to the next nucleophilic substitution reaction, reaction with alcoholic silver carboxylates. Carboxylic acids have the general formula RCOOH. H of carboxylic acid is replaced by Ag to give corresponding silver carboxylate. Alkyl halides react with silver carboxylates in alcoholic medium, so that AgX is eliminated as the byproduct and you get the main product as an ester. Esters are another class of organic compounds having the general formula R C double bond O R. And the general IUPAC name of esters is alkyl alkanoate. Just to go through the nomenclature, dear students. The example taken here is that of methyl bromide. Reacts with silver acetate. CH3COOH is acetic acid. H is replaced by Ag, hence it is called as silver acetate. In alcoholic medium gives you the ester named as methyl ethanoate. Alkyl alkanoate is the general IUPAC name, therefore it is methyl ethanoate. So these are a set of nucleophilic substitution reactions. Now the next set of reactions are reaction with metals. Two important reactions, reaction with magnesium metal, reaction with sodium metal. Let us look to the first reaction, that is reaction with magnesium. This is a very important reaction wherein alkyl halides react with magnesium in dry ether medium. Dry ether refers to free from moisture. To give the corresponding products having the formula RMgX, alkyl magnesium halides, or they are also called as organometallic compounds where magnesium is a metal, or they are also called as Grignard reagents after the discoverer Victor Grignard. If you take an example of bromoethane or ethyl bromide, reacts with magnesium metal in dry ether medium to give ethyl magnesium bromide C2H5MgBr. So these are organometallic compounds. Now the next reaction is a named reaction which is an important reaction called as Woods reaction. In case of Woods reaction, two molecules of an alkyl halide Rx react with sodium metal in dry ether medium to give the product as a higher symmetrical alkane. Look to the elimination there. 2NaX is eliminated as the byproduct. Symmetrical alkane refers to an alkane containing even number of carbon atoms. Never will the product have odd number of carbon atoms. If you look to an example taken here, you will understand it much better. Ethyl bromide reacts with sodium metal in a dry ether medium. If you eliminate 2NaBr, the product obtained will be N-butane having 4 carbon atoms, that is even number of carbon atoms. This reaction is called as Woods reaction. Now another reaction, that is reaction with sodium, which is similar to Woods reaction but slightly different. It is a named reaction called as Woods-Fittig reaction. Now here the reaction is similar to Woods reaction but slightly different. Look to the reaction there. A mixture of aryl halide, C6H5X is aryl halide, sodium metal and alkyl halide on heating in a dry ether medium. X minus is replaced by R to give the product as alkyl benzene, or it is also called as alkyl arene, and 2NaX is eliminated as the byproduct. This reaction is called as Woods-Fittig reaction. To take one particular example, bromobenzene reacts with sodium metal and methyl bromide or bromomethane in a dry ether medium to give the corresponding alkyl benzene, methyl benzene, which has the popular common name toluene. Sodium bromide is eliminated as the byproduct. So these are the reaction with metals. One is with magnesium, the other with sodium, wherein there are two named reactions. One is Woods reaction and the other is Woods-Fittig reactions. So these are the different chemical properties of alkyl halides or monohaloalkanes. Let us continue further.